So this is the question that if a is diagonalizable, then compute e raised to the power a, and this is a very important question. Suppose a is diagonalizable, then a is similar to the diagonal matrix. Okay, so a, there exists a non-singular matrix P such that P d P inverse is equal to A for D is equal to n cross n diagonalizable matrix with the eigenvalue of A down its main diagonal. Sorry. So thus A, since A is a diagonalizable matrix, so we can write it A raised to the power n is equal to P d raised to the power n P inverse, and we can easily prove this. I hope you don't have any issue to how this term comes. So for all n as before, therefore, so just write the series of e raised to the power a is equal to I, and where n is the order of a plus half 1 by 2 factorial a square. Similarly, you can easily open this series. So since a is similar to the diagonal matrix, and so hence a square is similar to the d square matrix, and similarly a cube is similar to d cube. Okay, we can easily write this. So you can easily see that p and p inverse we can take a common, so this will be e raised to the power d. Okay, now move to the another step. So to calculate e raised to the power d, why? Because we need to calculate e raised to the power a. So for finding e raised to the power e raised to the power a, we have to find e raised to the power d. So d is equal to the diagonal of lambda 1 to lambda n. So d raised to the power r upon r factorial is equal to diagonal of lambda 1 raised to the power r upon r factorial. Okay, because d is actually the diagonal entries of that particular matrix. Okay, so d raised to the power n is actually the diagonal values, and all the diagonal values in the form of lambda 1 raised to the power r upon r factorial. You can easily calculate just putting lambda 1 here. So summing from r 0 to infinity, we can see that e raised to the power d will come here. This value will come here, diagonal of e raised to the power lambda 1 up to e raised to the power lambda n. Okay, just because we are adding up to 0 to infinity times, so you will get the series of e raised to the power lambda 1 corresponding to the lambda 1. Similarly, corresponding to the lambda n, you will get the series e raised to the power lambda n. So to understand this, let us take an example. Let's take a is equal to -1 to 0 1. Then we can see that a is equal to p inverse for p is equal to 1 1 0 1, p inverse equal to 1 -1 0. You can easily calculate it. Okay, you just need to find its characteristic polynomial, then find its eigenvalue, and you will see that the geometric multiplicity and the algebraic multiplicity both are the same. So this is similar to the diagonal matrix. Okay, and the lambda 1 will be your -1 and 1. So what is our goal? Our goal is to find this e raised to the power a. So I have already explained that this e raised to the power a is equal to p e raised to the power d p inverse. Okay, so just put the value of p and this inverse of p, and e raised to the power d actually the diagonal entries e raised to the power lambda and e raised to the power lambda n. So we have two eigenvalues, lambda 1 is -1, lambda 2 is 1. So e raised to the power this value, then this entry is e raised to the power 1, this entry. Okay, so you just need to calculate it. Okay, so you will get your result. This will be your result. Okay,